Okay, we have here a nice integral today. This one was sent to me by Sid. We've got the integral from minus infinity to infinity, e to the x times sine e to the 2x plus pi over 4 dx. Okay, we have kind of a lot going on here in the angle on the sine. I'm going to want to break that up, but I think before we do it, we could do it before or after, but let's do a u substitution because we've got, for e to the 2x, we can think of this as like e to the x squared, which is the same as what we have right there. So it's going to work if I do a u substitution for e to the x, then du is going to be just e to the x dx. So when we substitute, when you plug in infinity, that's still going to infinity. When you plug in minus infinity, e to the minus infinity is going to 0. For the du part, that's going to be, we've got the ex dx here, so all that stuff's going to be du. This is going to simplify down to sine of u squared plus pi over 4 du. And then on this here, what we can do is the angle sum formula for sine. So using that, we just get sine u squared cosine times cosine of the second part. So we're going to have cosine pi over 4 plus, then for the second part, we just reverse the angle. So it's going to become sine pi over 4 cosine of u squared du. But now cosine pi over 4 and sine pi over 4, these are the same value. Both these are going to be 1 over square root of 2. So then let's just rewrite it, factoring this piece out as a constant and splitting it up into two integrals, I think. So because we've got the same constant in both, we can kind of do it like big parentheses around the whole thing. And so the first integral is just going to be integral from 0 to infinity sine u squared du. And the second one, we've got a cosine, so it's going to be 0 to infinity cosine u squared du. But what we have here, it's just the Fresnel sine integral, the Fresnel cosine integral. These actually have the same value, and they're both going to be, we can write it as 2 pi over 4 or square root pi over 8. Same thing here, square root pi over 8. Just kind of memorizing the well-known value here. And so what we can do is put it together. We have 1 square root of 2, 2 copies of this, so it's going to be 2, kind of do it like this, 2 times square root pi over 8. Then let's see if I can clean it up. So let's multiply that in. So let's see, we'll have 2 square root pi, 2 times 8, 16. But then square root of 16 is just going to be a 4. So we can do, let's see, so we can do this as 2 times square root of pi over 4. So for my final solution on this, we just get square root of pi over 2, and that's it. Okay, there you go. Thanks again to Sid for the problem. Thanks everyone for watching. Have a good day.